coded, and you can watch it anytime. Okay, so last time we covered a few items, some common operations in MATLAB, vectors, matrices, extracting part of the matrices. We have seen the sum of the common operations as well as the element-wise operation, correct? We have seen the row vector, how to create a row vector, how to create a column vector. We talked about the column over there, right? And we say that this column will create a new row. So that is row number 1, this is row number 2, that is row number 3. We talked about creating matrices in MATLAB, and as I said, it is done using the semicolon. Okay, then we talked about extracting part of the matrix. We said matrix, then rows, comma, columns. So the first index represent row number 1 or 2 or 3 or a range of rows, yeah? And that one stands for the column 1, column 2, column 3, column 4. And we said if our matrix, we want, let's say, that element, which happens to be in row 5 and column 2, then what we write in order to extract that element was 5, 2. And by writing matrix, by the way, I'm saying that's the name of the matrix. Let it be A, for example. Then just A, parenthesis 5, 2, and you will extract that element. Okay, we have done that last time. What else? We specified, so we created a vector using the colon operator, yeah? Using the colon operator. And the colon operator says, do something, create a vector from 0 with an increment of 2 all the way to 10. And if the increment was 1, we can easily say x equals 0 colon 10. And this will create a vector. This function or this command is equivalent to 0, 1, 2, 3, all the way to 10. Okay? It will create a row vector with elements 0 to 10. The increment, if you did not specify it, MATLAB takes the increment as 1 by default. But if you specified it, let's say I want the increment to be 3, then this will create 0, 3, 6, and so on, okay? And 9. Right. Then I described the colon operator. How can you extract part of the matrix, slice it, dice it, according to this table. We discussed it last time. What else? We talked about some of the common functions in MATLAB. Ones, zeros, size, yeah. And we said that ones creates a matrix with R number of rows and C number of columns, where all the elements are 1, 1, 1, 1, 1. And you will see later in this course that this function is handy in some situations. Right? Zero is the same thing. If you go to MATLAB, Z rows 4, 5, it will create 4 rows, 1, 2, 3, and 4 with 5 columns, column 1, column 2, column 3, column 4, and column 5. Okay. Similarly for the size, if you say size not specify or I did not store this zeros 4 to 5, but I know that it's available in answer. So I can say size of answer. And the size of answer is 4, 4 space 5. What does that mean? What does that mean?
4 rows, 5 columns.
Exactly. 4 rows, 5 columns. Okay. Okay. Right. Next here. Back to the presentation. Right. These are some of the common operations or functions defined in MATLAB. That operator, we talked about it last time. So if you have CLC, you can clear the screen. If you have something like x equal to 1 with increment of 5 is 0. 0 with increment of 5 all the way to 20. Okay. That is 0, 5, 10, and okay. This is a row vector, guys. And to make sure that this is a row vector, size of x, it says 1, 5, which stands for 1 row, 5 columns. Right. If you want to transform this row into a vector, which command you are going to use?
X comma.
Okay, that comma will transpose the row vector into a column vector. Okay, that will transpose the row into column or column into row. Okay, so if you had, for example, if you had something like a matrix with 7 by 5, which means 7, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5 columns. Okay, that is the column, and 7 rows, and you want to transpose it to simply a transpose, and it will create something of 5 by 7. Okay, we're basically swapping rows into columns. Okay. What else? Yeah, we talked about all of that. Let us move on. The inverse is the inverse of the matrix. We will see. We will look at it later on in the course. Fine. Let's move to another aspect right now. And Shabab, before moving to the other aspect, I will send a poll. Let me write on the general session or the general channel of this course. Let me create a new poll. Just a minute. MATLAB now. Let me see what we have. Yes, no. Okay. Pleasurable. Keep it anonymous. Shares. Okay. Pleasurable. I wrote a poll on the channel. Do you have MATLAB? I need to know the answer right now. Do you have an access to MATLAB right now? So 3 people said yes. You can see it over there. Okay. 4 people, 6 people. Okay, I'm just waiting. If there might be access to MATLAB or at least MathWorks, the account on MathWorks, please go ahead because it is time. So far, 12 people answered this question. طيب البداية شباب. You either have access to MATLAB or you don't have an access to MATLAB, right? Still, we are missing at least 5 people. Okay. Still missing 4 people. Okay. Right. So the majority have an access to MATLAB, which is quite good. Shabab, there is something which I did not discuss last time. As we talked about the syllabus, part of the marks that you are going to gain is with your interaction in the class, صح? So for example, if I say, do this exercise or answer this question, I expect that you go and your name, under your name, you can see plenty of names over here, and you go to Hassan, for example, and let's say Hassan, for example, is doing some of the class notes. يعني كتبت شيء في OneNote, which basically you are answering some of the questions that has been asked in the class. So at the end of the semester, guys, I will evaluate you based on the work that you are doing in the class notes. So I ask you, for example, let's do this exercise. So at the end, when we do all that exercise, I expect to have something written in this class or in this note. Right? And based on that, you are going to be evaluated for the classwork. Is that clear? طيب.
Yes.
لحظة دكتور أروح عند اسمي في كلاس.
Yeah. For each one, for example, you see your name. There are class notes, quizzes, homework, handouts. So your work basically should exist somewhere there. And at the end of the day, at the end of the semester, or whenever we are doing the assessment for this part of the course, okay, I will look at your coursework. Is that clear?
أوكي دكتور.
تمام.
بس هو دكتور يعني نتفق على شيء إن إحنا نكتبه في الهوم ورك أو الكلاس نوت عشان.
لا, for example, no, I will be clear. For example, I will say that, okay, you know what, guys, let's do such and such. Let's plot, for example, it's not working. Plot the sine function, or plot the cosine function. Okay, when you do that exercise, I will tell you, okay, put it in your class notes. Yeah, but I will be very clear on that topic. طيب, let's move on. Now let us move to plotting in MATLAB. Let us do some plotting in MATLAB. Okay, so in order to plot a function, you need a bunch of data, and you need the function that you are plotting those data against. صح? So for example, if I want to plot, let's say the sine or the cosine. Okay, so let's say from minus pi all the way to pi. This is the x-axis. And against the x-axis, the y-axis is the value of the sine function. So we need two vectors in order to plot anything. We need, let's say, x and y. This time, let's say x goes from minus pi to pi. That is the range of x. So how can we define x? Going from minus pi all the way to pi. How can we do that? By the way, we discussed that last time, or we discussed creating a vector last time. So I'm waiting for your suggestion. What shall we do in order to create this vector, x vector? You either say it, or you raise your hand, or you write it in the chat. And I'm looking at all options right now. طبعا تفضل عبد الله.
دكتور we write x افتح قوسين يعني ونحط هذا الباي.
Okay, x, then let's say the square bracket. طيب, square bracket, then what?
نحط الماينس باي وباي.
Minus pi. طيب, how can I write pi in MATLAB?
PAI.
PI, right? PI. Just let me pause for a second, just a minute. Okay, I'm back. Right, so we said pi, okay, come on, okay. Then what shall I do next, Abdullah? Or anyone?
نقطتين.
Okay, colon.
بعدين الباي عادي.
بعدين الباي. Okay, Shabab, what do you expect to see here? Last time we said
A line of pies.
a line of pies. So, for example, pi last time was defined as 3.14. Okay, the value of pi. And if I say x equal to minus pi to pi, how many elements do you think you will see? A lot of elements, small number of elements. So what does that mean?
Maybe two.
Infinity.
No, because we say if you just specify column, right? That means you are incrementing by 1. So minus 3.14, minus 2.14, minus 1.14, 0.14, all the way to 3.14. Yeah. So it's not a lot of elements. Let's do that exercise. Let's hit enter. Yeah. Minus 1. So you can see if you want to plot such a function, it won't be smooth. بتحصلون شيء من هالشكل. يعني قصدي it's not a smooth function. It's not as smooth function as you would expect. But you know what? Let's keep it like that. Let's keep it like that. طيب, I defined x now. How can I define the y values? We define the x-axis. I'm sorry. We define the x-axis. X is defined. How to define the y-axis right now? How to define the y-axis?
Y from -1 to 1.
Y from -1 to 1. No, I want to plot the cosine function. I want to plot cosine function. So the way to do it is basically to define, let's say that y equal to simply cosine of x. And in doing so, guys, this is the value of cosine minus pi, because that is minus pi. Then this is minus pi plus 1. This is minus pi plus 2. This is minus pi plus 3 plus 4 plus 5 plus 6. Okay? And this is the equivalent cosine function of whatever argument over there. Is that clear?
Yes.
Okay, clear. طيب.
Yes.
We defined x and we defined y. How can we plot the function right now? Simply plotting the function as plot x versus y. So that is the function that we have. It goes from minus 3.14 all the way to 3.14, and you can see that the function is not smooth, right? You would not guess that this represents a cosine function. So what shall I do in order to make it a smoother function?
بنحتاج كل الأرقام بين ماينس باي إلى باي.
Okay, so basically you're saying, let us increase the density of the points and the x-axis, صح? Okay, let's do that. So what do you suggest? Right now, x increases by 1. So what shall I do in order to have more points?
خلنا نسويها
Multiply
0.1.
0.1.
خلنا نخليه not 0.1.
0.1. Okay, let's go ahead, guys, and define x as minus pi with an increment of 0.1 all the way to pi. You can see that this time we have 63 elements. Okay, 63 elements. Okay, so what do you think? Shall we plot x versus y right now? What do you think?
No, we didn't change y.
We did not change y. We did not change y. Perfect. Plot. Vectors must, error using plot, vectors must be the same length. What does that mean? If we look at x and y, there is a function called length. The length of each vector. So the length of x is 63. The length of y is 7. Well, simply we did not update y. The previous vector was not updated. The previous vector was minus pi with increment of 1 all the way to pi, where the new, that is the old one. I'm sorry. Where x new equals minus pi with increment of 0.1 all the way to pi, right? So that is y old, but basically we did not update y new. So what shall I do? I recalculate this vector. Simply y equals cosine of x. Okay, but just imagine that this x or that y had 10,000 elements or 100,000 elements. Okay, it's not. It doesn't look nice that your screen is just filled with numbers, right? Because I'm not interested in each number. I want those 100,000 elements to be stored somewhere in the memory. I'm not going to investigate each number. Adil? So what shall I do in order to stop printing those values on the screen? All what you need to do is to say y equals and put semicolon at the end. What does that mean? It basically means don't show that operation in the command window. Execute it, but don't show it in the command window. Is that clear? Don't show that operation in the command window. You know what? Let me go ahead and delete y. Okay, and let me go ahead and execute this function. Notice this function has been executed. I have a new vector of y, and that function was not printed on the screen. Okay, so every time you want to do certain command, but do not execute it or print it on the screen, you put a semicolon at the end of the function or the line. Okay. Yeah, let's go ahead. Let's plot the same function. So do you notice that each time sometimes I'm doing the same command again and again? That's why it is always better to use the command history. Right now, I can just either drag and drop the function, okay, and hit enter, or let me just close this function again. Or I just double click the command, and it will be executed in the command window. That's why I'm saying always make sure that the command history is docked to your layout, MATLAB layout. Okay. The function looks much better now, right? The function looks much better. All right. Okay. So suppose I want to increase the range. Rather than having it from -pi to pi, I want to have it from -2pi to 2pi. What shall I do?
will be the same thing, but you will put 2 before the pi.
Okay, go ahead. Execute those commands. Define x, define y, print the function, and put it in your class notebook.
Okay.
Put it in the class notebook or class notes. Okay.
Doctor, do you want it like a picture or what?
Yeah, but picture is fine. A picture is fine. Picture or command. Or, by the way, you can copy this function, the figures as well. Copy the figure, for example. I will come here to my notes and I can paste it. Okay. For example, I can go to the command window. 1, 2, 3. Okay. Copy those commands. Go to my class notes. Where is my class notes? And print it over there or paste it over there. Okay, so at the end of each lecture, you are basically building up your coursework. Okay, you are building up your coursework. All right. Are you done? Is anyone done? I'm looking right now to increase the range for x rather than having it from -pi to pi. Let us increase it from -2pi all the way to 2pi.
دكتور نحط انكرمنت ولا بدون؟
As you wish. If you want to put the comments, but usually we don't have a lot of time, right? Just put the important parts in the class notes. Right. I think this is a straightforward exercise. All what we need to do is the following. By the way, let me clear everything and let me close everything. All what we need to do is to define x as x minus 2 times pi with increments of 0.1, it was smooth, all the way to 2 times pi, and do not show this vector, then define y as cosine x, again don't show it, and then plot x pi. And this is the cosine function. طيب. Let's move on right now. What do we need to do? We need to add a title for the axis. So these axes are shown with names. Okay. So simply in MATLAB, we can define that by X label. This function says, let's switch to MATLAB and X label, and look at the syntax. Let me just put X. Notice X is written over there. Okay, and let's define the y-axis as y label. Sorry, y label, comma, and I will call it cosine. And you can see that cosine is written on the y-axis. Okay. So now you can see that we can plot a function, define the labels for the x-axis and the y-axis. Let's move on. Let's increase the complexity of this figure. Let us add the sine function on the cosine function. So let's basically plot both of the functions, the sine and cosine. So what shall we do? Notice guys, if you, for example, if you go ahead and say plot x versus, you know what, let's close this function, or close this plot. Okay, let's plot x versus cosine of x. If you did not define what is y, you can right away define the function itself, cosine of x. Hit enter, it works fine. طيب, if that works, I can go ahead and say plot x versus sine of x. The cosine function disappeared. So basically, the sine function replaced the cosine function. Is that clear? But I don't want to do that. I want to have the cosine function and I want to have the sine function on the same graph. So how can I do that? Basically, let me close that. Let us start with plotting the cosine function. And then I can say, what does that command mean? It means any new plot, just to plot it on the same graph. Okay, so hold all, and let's go ahead and plot the sine function right now. Plot x versus sine function, and you can see that I'm plotting both curves on the same graph. Okay, how did I achieve that? Just by saying hold all. Okay, similarly, I can plot x versus tan right now. Tan function, and because of the singularities near zero, because the function goes to infinity, you are looking at this weird kind of graph. So let's close it and do that one again. 1, 2, 3. This is sine and cosine. طيب, how can we tell the reader that the blue curve stands for sine and the red curve stands for sine? You need a legend, right? You need a legend on that graph. Okay, so basically we can add that by the legend function So if I say legend, comma, cosine, then you see that the blue curve has a cosine legend. Okay, and I can say the second one, sine, is for with a sine. So by the way, MATLAB does not understand which one is sine, which one is cosine. MATLAB understands that the first curve you called it cosine, the second curve you called it sine. So just make sure that that you are referring to the right curve. بمعنى آخر, the first one stands for the first function, and the second legend stands for the second curve. And if you went ahead and said, you know what, this is sine, that is cosine, it will print exactly what you asked it to print. But that is not correct. واضح اللي بغيت اقول لكم؟
ايه واضح دكتور، ترتيب مهم يعني.
Okay. مهم exactly. ترتيب. Okay. طيب, so we printed that. Okay, next let's say I want to change. Let's see, you know what? Let's create now a new figure. Let's create a new figure. Let me call it figure 2. So you can see that now you have figure 2 and you have that figure 1. Okay, figure 2 and you have that figure 1. So now, what do I want to do? Yes, let's print. Let's plot x versus x squared. Right, Shabab? X versus x squared. First of all, do you think this will work?
We'll see.
I think so.
Maybe, doctor.
Maybe. Right. You know what? Let me go ahead. It says incorrect dimensions for raising a matrix to a power. Check that the matrix is squared and the power is a scalar. To perform element-wise matrix powers, use dot to the power. Shabab, what does that mean? I told you previously, MATLAB considers everything as a matrix. Even if you define 1 or 2, this 2 is a 1 by 1. Okay, it's a 1 by 1 matrix. This scalar quantity is a 1 by 1 matrix. Adil? And notice, what do you have x over there? X is a vector which has 1 by n. And what? And columns. Adil? N columns. So when you say x squared, what does that mean? It means something with size of 1 by n times something which has the 1 by n. And you can see that those inner dimensions are not equivalent. So you cannot do the matrix operation. It is not defined, right? What you really want to do is to take each element من هذين and you square it. Squared, 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 and so on. Adil? That's why we need to define the element-wise operation. That's why we need to say dot to the power 2. هذا الشيء اللي بغيت أقول لكم ذاك اليوم. The dot to the power, or the dot multiplication, or the dot division is important if you want to do the operation on each element of the matrix, of the vector, of the higher dimensional tensor. Is that clear?
Yes, doctor.
Yes.
Can you do an example, Doctor?
But yeah, I mean, let us fix it. Let us fix it. So in order to fix this thing, basically, I need to say, شباب لاحظوا وياي, figure 2 is empty, right? Figure 2 is empty. Okay, let's say now fix it by saying x, plot x versus x dot squared. So the x squared function is plotted in a right way. Adil? And we can add to this figure x label. I can call it x. Notice I have x label now, but I don't have the y label over there. So I can fix it by saying y label or x squared. I have now x squared, correct? And I can add title for this function or for this graph, title, my first figure and MATLAB. I'm sorry, this is long, but just to my first figure in MATLAB. Okay, my first figure in MATLAB. What else? Yeah, Shabab, sometimes I want to see the crossing at the 0 or it's kind of hard to read this function or this graph. So sometimes it is handy to put the grid. I'm not sure if you can see those grids, but I can easily see that the value of the function I'm moving to is something around 16, 17. Okay? So adding the grid is handy. Plotting. Okay. What else? What else? I want to plot. Let's say x versus x cube on the same figure. What shall I do now? هرسم x square. I want to plot x. X square is done. I want to plot x cube. What shall I do?
أول شيء hold all.
Hold all. All right. This is one option to say. One option to say hold all. Then plot x to the power 3. And it worked, right? It worked as well. Okay, it worked as well. طيب, طيب, suppose I want to change. let me stop the hold all. Hold off. What does that mean? Okay, don't plot the new curve on the previous graphs. Okay. Now you know what? Let me change. Let me do something else. Let me say figure 3. I have a new figure, and let me do the following. Let me say plot x versus x squared. But about this time, I want the curve to be red rather than blue. So I can do that by saying comma R, which stands for red, or I can change it to another color. A B standing for blue, or maybe G stands for green. Maybe I want to do something else. I want it to be green as well as with a dashed line. So now it's green, but it has the dashed line. Maybe I want to add it with rather than continuous, I want to have it with the stars. And because we have so many values, that's why you can see the stars very close to each other. Okay. So by adding those identifier, you can change the way you are plotting the function that you have. I'm adding some of them over there. These are for the colors. These are for the symbols. These are for the type of line that you want to plot. Is that
يعني دكتور الألوان مو على طول أول حرف.
الوان you can مو لازم أول حرف، لا مو لازم أول حرف، يعني احنا يعني
Okay.
let's see.
نفس البلوك، أنا كنت بسألك البلوك شلون.
Say something like this. Will it work؟ صارت النقاط بس طبعا صغار صايرين. Let me change it to okay. It's black and with dotted line, or maybe with a plus. Okay. Is that clear?
أوكي.
Okay.
زين دكتور بقى عندي سؤال. الحين دا أنا فاتح فيجر 3 وبعد فيجر 1. شلون يعني؟ شلون أسويها؟
Okay, you have to define the axis for the plot. For example, we can say that P1, okay, and طبعا ما بيصير بس يعني we can always say figure 4, okay, and I can say, for example, plot P1 versus x squared. Okay, now in figure 4 I have that, okay, and I can say that P2 figure 5 figure 5, and I can plot P2 equal to plot x versus x dot to the power 4. Okay, this is to the power 4. Then you can, because now you kind of store the function or store the plot, and with a certain handle, we can always go back to that handle and modify it. يعني الحين شوف هالرسمة مثلا. This is P2, right? Which basically was x what? X squared. والله P1 كانت.
لا هذا B1 دكتور.
P1. Let me go ahead and say P1 equal to plot x versus sine of x rather than x squared. You can see that this plot, which was x squared, has been replaced by the sine. All what we need to do is create a handle for the plot and go back to that handle and modify it.
أوكي دكتور تمام.
Okay. طيب شباب. Can we proceed in order to? Can we take 20 more minutes? Then we stop at that. I need a few more items to cover it with you. Writing a script and functions, and I want to describe something else in MATLAB, which is really handy. I really want you to use it, which is called the live script. The live script. You know what, guys? Let's stop for 10 minutes. يلا مو مشكلة، خلينا نوقف 10 دقائق. Let's stop for 10 minutes and come back after the break. We will continue this session.